we have learned about the information about torsion. Okay, we have learned about some stress strain distribution and also the torsion formula. So can we demonstrate a little bit on the what you call it, the problem solving examples? So before we proceed with the problem solving analysis, let me remind you some specific or some guidance to do the problem solving related to torsion. First, we have to identify the internal loading. Okay, so is it the shaft perpendicular to axis? What is the free body diagram to obtain the internal torque? Okay, so that is the objective of identifying the internal loading, perpendicular to axis. If not, it cannot be solved due to torsion is rotating about longitudinal axis. Then we identified the free body diagram to obtain the internal torque. Okay, so secondly, we compute the section property. So what are the section property? So the J. So is it hollow or solid? So use appropriate equation to calculate the section property. And then the third one, we can proceed with the determination of shear stress by using the torsion formula. Okay, T over Z. So these are the three steps that could assist you during your problem solving. Okay. So example number one. Let's say we have a series of circular discs assembled through a shaft. Okay, fixed at the end. So we have the torque here, 4,250. This we have 3000, and also this is 1250 kilonewton millimeter. Kilonewton millimeter. So the question asks you, okay, the cross section of AA demonstrated by this. Okay, this is B, this is DA. So the row is 75 mm. The C is 75. The row is 15. Okay. A section. So what are the shear stress developed at point A and also point B, located at 75 and 15 millimeter respectively? So how are we going to calculate? So the first step, first we have to identify, is it the shaft is perpendicular to the axis? Yes, we can answer it yes, because it is perpendicular. So what is the free body diagram of the problem? So the free body diagram, okay, for this segment AA, because we want to identify the AA, so we left only the two to do this. Okay, so what happened here, and then here, then we have 1T. Okay, I would use this 4250 3000 and also T. So how can we calculate the T? Okay, moment of x equal to 0, summation of mx equal to 0. So we have okay, first you have to use the right hand rule for torsion. Okay, so means that the your thumb represent positive if the thumb is moving outward. Thumb move outward, so it is positive. Okay, so meaning that the anti-clockwise refers to the positive moment, positive torque. So we have 4250 minus 3000. Okay, so we minus T equal to 0. So T equivalent to 12550 kilonewton. So meaning that positive 1, here we have positive T. So initial we assume that it is on the other way, but finally we conclude that the T is moving inward as positive number this exists. Okay, so how about the section property? The second part is the section property. Okay, so is it solid or hollow? So it is solid one, so we use the pi over 2, okay, rho squared. So we have identified as 4.957 times 10 power of 7 millimeter squared. So and then you solve the problem by identifying the torsion formula. So the first part require at point A, which is located 75 mm, the rho. So the tau is equivalent to tau A is T C over J. So T is 425, oh not 2, the T is 1250. Okay, the C is 75 and the J is 497. So you will get the answer 1.89 megapascal. So likewise for point B, located 15 mm the row. So tau B equal to 1250 times the 15 times the 497. So you have about 0.377 megapascal. Okay, so remember three steps, and also the formula of torsion formula. So the section properties of J, solid or hollow, that will determine the success of your problem solving. Thank you.